All right, welcome everybody to Math Day. This is our second talk of the day. Our speaker is Dr. Gary Herman. He's contributed to mathematics education at the state level, serving on committees to revise the Ohio Mathematics and Computer Science Standards and model curricula. In 2024, he co-presented with two other UF faculty at the Carnegie Project on the Education Doctorate convening in Honolulu, Hawaii, on the use of AI in qualitative data analysis. His work reflects a commitment to connecting rigorous mathematical thinking with innovation, leadership, and real-world impact. Before we get started, I'd like to thank Ricky for all of her help in setting up Math Day. If we could. She's done an amazing job. I'd like to plug the Oilers Escape Room from the Oiler Math Club that's happening 6 p.m. to 8 p.m. in Davis, rooms 179, 180, 181. And for Gary, we have a gift for you.
All right.
To say thank you.
All right, thank you.
So, Dr. Gary Herman.
Thank you. Thank you. I'll leave that right here right now. Thanks. All right, welcome, and thanks for having me here to talk this afternoon. It's great to be here. I told this morning's group that in honor of Math Day, I brought out my math tie and my math socks for today. I did teach math at high school for 10 years before getting into curriculum, and then now coming to the university this year. So today, and now I'm teaching in the College of Education, not in the math department, but I am more than willing to help out with things like this as well. Today we're going to be talking about artificial intelligence because it's everywhere right now. It's being embedded into all different types of devices, platforms, vehicles. It can generate essays, images, data tables, whatever you need it to instantly. But what I want to talk about today and this afternoon, slightly different than what we talked about this morning, is focusing not just what an AI can do, it's how we think about the information it produces. And so we're going to get to an essential question in just a bit here that's going to be kind of the driving question for this afternoon's presentation. But I just wanted to start off by, Dr. Blodgett introduced me there, and like I said, he didn't happen to mention that I actually did all three of my degrees at Findlay. So I did my undergraduate in computer science and math, and then my master's and doctorate both here. So for about 30 years, off and on, I've been a student at Findlay, and now I'm teaching here in the College of Education. I've worked both as a high school teacher for 10 years and doing curriculum, where I worked with 9 local districts in Putnam County, supporting them from data analysis to professional development to working with their administrators on leadership. And then, as he said, I worked with AI on my doctorate, and that's really what got me digging deeper into AI and using it in a lot of ways. So I was very fortunate to go and be able to present on the use of AI in qualitative data analysis. One other thing that I'm going to bring up, I didn't bring up this morning, and I just bring it up because it's a personal thing that I'm self-conscious about, and so I just want to share because it'll make me more relaxed being up here, and that is, in 2008, I had a really bad virus that attacked my nervous system. I went undiagnosed for like 8 months. I thought I had cancer. They thought I had mono, or they ended up finding I did have mono. They thought I had MS, all these things, and it ended up being a virus that attacked my nervous system. And so I have I have nerve damage in my legs. I had to go through, I was in a wheelchair for several months, relearning to walk, and everything is fine now, but I have very spastic muscles in my legs. And so when I'm up in front of people, sometimes I'll like catch my foot on something as simple as this. In fact, I almost caught my foot walking up the stage. So if I fall, it's just because of that. It doesn't happen a lot, but it happens enough that it's regular, and it's just a thing. So if you see me walking and I catch my toe or I walk stiffly, it's because of the nerve damage in my legs. So no big deal. It doesn't hurt me. I always say it's like having a cramp in your leg 24/7 without the pain. That's basically what it's like. So going into our big question of the day. A question that I want you to think about is, if AI can generate answers instantly, then what is the role of human thinking? And so I want you to take just a few seconds to think about that on your own. if it's doing all this stuff, what is the role of human thinking in this? So I want you to take 30 seconds and talk to somebody around you. I don't care if it's a group of 3, people in your row, somebody next to you. Just talk about that, because we're going to revisit this later. But I want to see if your attitude changes in the next 30 or so minutes. So talk to somebody next to you about this question. All right, I'm going to cut you off. We're going to revisit this later. But really what we're going to be talking about today, this is the heart of it. You know, some of the times that the stuff that AI can give you is misleading. But we're going to talk about how AI also works, what the mathematical thinking is involved connecting to AI, and then why humans are more important than ever when we're dealing with the world of AI now. So some of the things that may happen, and I brought this up because these were big issues in the news, is that AI can generate fake sources. And so if there was 3 big things just in the past, I would say 2 years, and here are the headlines to go along to show, and I'll kind of briefly explain these 3 events. The first one happened about 1.5 years ago in Alaska, where they literally, the State Board of Education, a person there was working on a cell phone policy for the entire state, used AI to help write the report. It included studies that then made it through all the people, got approved by the State Department of Education, and was sent out to all the schools. The studies that were cited don't exist. Last year, the Department of Health and Human Services released a report on children's health, included non-existent research studies. And then just a few months ago, a judge fined a lawyer $12,000 because the lawyer included AI-generated cases in their analysis for support of a patent case, and those sources didn't exist. So this is why it's important that as users of AI, that we are critical thinkers and that we actually look at what is real and what is not real. These things aren't just some minor things. Like if you're using an AI chatbot and you're talking with it and it gives you a wrong answer, like, okay, you can deal with that and fix it. But you can't just be using this stuff in research and in actual papers that you're doing for academia or any kind of political or legal purposes. But why do these things, if those get by all those people and they got into law cases and they got into public policy, well, how does that happen? And it happens because what we call the illusion of authority. Numbers have a lot of authority. You know, statistics, the studies that they were citing had statistics. They had citations. They had graphs. They had things that research shows included in them. And when people do that, that gives authority to it. And it's funny, there was a little comment when I was looking into this that says, if you know, 90% of statistics are made up on the spot. 90% of statistics are made up on the spot. That's kind of a joke, but it's, you know, it is a joke. But it's funny because we just take numbers for granted. Somebody tells you a statistic and automatically you kind of just think it's right because it's numbers. Where are they getting this number from, right? So it works because numbers give things a sense of authority. Numbers give power to statements that you do. But we need to think about, and one of the themes that you're going to hear me talk about throughout this is that when we're doing math, math doesn't just help us calculate, it should help us question. So when we see statistics and we see data and we see research out there, the real question shouldn't be, what does the number say? It should be more about, where does the number come from? So an example here I want to show you kind of just starts to make this point. So this is just a made-up graph. I actually used, again, different AI tools. One of the really good tools to create some images for slides is Notebook LM. So I use Notebook LM to create some of the images for some of these different slides. So this is a made-up graph, but if you look at this quickly, it would appear that this company is doing well. And for any of you that have taken any statistics classes, should know that there are some things that are in here that are skewed. First of all, the vertical axis starts at 95, which makes those changes look a lot more drastic than they really are. And then also, the sample size is 4. So that's a little bit concerning as far as the sample size as well. So if you look at this, the graph isn't technically wrong. You know, there's nothing inaccurate about it, but something can be accurate and still can be misleading. You know, the data is correct, but the way it's presented affects how we interpret it. So whenever you're looking at data and statistics, you need to question what is the background of the information, and how was it created, how was it sourced. So again, not looking at just what the numbers say, but where did the number come from? So again, some of these things I talked about already, but these 3 key areas here are going to be something we talk about a few times here. And that's because when you look at graphs and when you look at data that's presented to you, it's not necessarily always wrong, but it can still lead you to drawing a wrong conclusion. So when it's there, think about where did the data come from? How was the information gathered? And are they making assumptions about the data when they do their calculations that could be misleading? Math trains us not just to compute answers, but to question them. And that's one of the key takeaways you should think about when you're going through your math training. You can have accurate numbers, you can have accurate calculations, and you can still reach the wrong interpretation if you don't question the data behind them. So let's talk a little bit about where we're seeing a lot of numbers and a lot of data now in our society. And that would be artificial intelligence. So artificial intelligence, and in this morning's session we talked a little bit more about the nuts and bolts behind artificial intelligence. But in essence, you have lots of data, you know, billions and billions of data sets that the artificial intelligence has been trained on. You have some sort of AI model or tool, whether that's some sort of a generative AI tool or something built into a different platform, and it outputs some sort of prediction. Again, artificial intelligence is great at creating and generating lots of stuff: text, images, paragraphs, emails, whatever it may be. But it's important to understand what it's actually doing is just giving you a prediction. You know, when I've worked on training a lot of teachers on using AI, and one of the first things I tell them is realize it's not Google. You're not searching something. It's a generative tool that's creating text for you. And that text is based on prediction. And so, again, you got to understand you're not searching for an answer. You're creating something based on prediction. And that key difference is important to understand when you are using AI. This morning I kind of used this example, and they bring it up in this slide again, is that if you want to drill it down to a very simple analysis, AI is basically like an advanced autocomplete from your phone. Your phone, when you're texting, is suggesting the next words. AI is like that, you know, but times a billion. It predicts what's going to come next. So let's do a quick history lesson here. If we want to think about AI, one of the first mathematicians that brought this question up was in 1950, Alan Turing. He proposed the question, can machines think? And in his work, he came up with what's called the Turing test. So the Turing test is a pretty simple test, and it simply says this. If a machine can carry on a conversation and a human can't decide whether that is a machine or a human that they're talking with, the machine can be labeled intelligent. So, let me say that again. if a machine can carry on a conversation and the human can't tell whether they're talking to another human or to a machine, that machine can be considered intelligent. But notice that there's something very important missing from this test. Passing the test doesn't necessarily mean that the machine understands what it's talking about. The only criteria for this test was that it sounded like a human, that it was conversational. So that explains something very important about AI systems that we're working with now in our society. They're incredibly good at producing things that sound right. They sound conversational, they sound human. But that doesn't always mean the information is correct. And that's a huge key. And that's what's so important about our use as humans using AI. So I used this similar slide this morning, and I'll give you the same spiel I did to them in case you weren't here this morning. This is a generalized idea of what AI is doing. You give it some sort of prompt here on the left, you put it through the function. I'll explain that in a second here. The function is all the learned rules, pattern data that AI has been trained on, and you get some sort of output, the generated response. It learns all these rules and patterns from data. The more data it gets, the more accurate, the better it is. Now, the reason I said there's a caveat in this is, because this is a math speech and this is math day, is I don't necessarily like to qualify this as a function, because any of you that use AI know that you can put in the same input and get a different output in AI, and which would mean that it's not a function. So I use that word function lightly. It's basically giving you that idea, the framework of what we're dealing with. But AI predicts patterns. And so it's predicting, like, based on all this data I have, here's what the output is. There's nowhere in there that says that this is the truth or that it's accurate. It's just, here's the output based on the patterns it knows. So what we have to think about when we do this is that we sometimes see things like we talked about earlier, those fabricated sources, those fabricated research studies that are out there, or other misleading statistics. The system produced things that look great. The output of those research studies looked very valid, but there's not really any part of the function in here. There's not anything in here that is validating any of those sources. It's just creating stuff that looks really good. So we have to think about who's evaluating the answers to actually see if they make sense. Because we have to think about data does not interpret itself. AI does not interpret itself. So if we think about AI generating all of this data very quickly, there's still something really important missing, and that is the interpretation. Again, all of these things don't interpret themselves, so that's why we, the human users of it, are the ones that have to provide that meeting. We have to have someone to evaluate the result. We have to have someone decide whether the answer makes sense. We were just having this discussion at lunch with a couple people about, students will sometimes give you an answer that makes no sense at all. Or what we need to be as good math students is be able to look at data and say, that doesn't make sense. Why? And so that's where the humans provide that extra layer of meaning. You also need humans to verify, is the information correct? We've talked about, I work, again, a lot with teachers and administrators, and we can have a quick fix of creating some sort of worksheet for students to do, but have we ever evaluated whether it's even accurate or not? And the same thing with you. If you as students are using it for something, I sure hope you're actually taking time to check it to see if it's valid or accurate, because that's what your level of the human part of it needs to be. So let's look at an actual example here, a more visual example. So that was a lot of words, but this was another good visual that I thought Notebook LM did to create an image of what I was trying to explain there. Over here on this left side, we have all of this raw data. I mean, there's tons of data out there now. Some of you may be data science majors that you're dealing with all this massive amount of data and how to interpret it. And then we have AI models over here to help, run analysis on it, all that stuff. And what we want to get to in the end is some sort of meaning or some sort of truth. Like, what is our goal? What is our end output that we want? But what we need in the middle there is that human interpretation. You, as users of this, and growing up in where you're going to have AI embedded into all things that you do, and never necessarily really knowing so much differently, you need to be able to contextualize that. Think about how it fits into the situation you're using it for. You need to be able to verify it. That's a huge thing. But you also need to be able to judge. Judge, does it make sense? AI is just predicting words. What it gave me, does it fit the situation I want it? If not, then you as a human make that decision of what to use and what parts of it are good and what parts aren't. So again, because there's nothing in here built into the systems where it's going to interpret itself. You do the interpretation part. That's why those thinking skills, those critical thinking skills are so important. So here's a simple example. This is very basic. This was just a graph actually created by ChatGPT because I was asking for something simple. So a simple graph, hours studied, test score. If you were to look at this quickly, it would just seem to imply that it's pretty straightforward that students that study more score higher. But there is an interpretation question as humans we could think about on this, and that is, does studying cause higher scores, or are stronger students simply studying more? The data shows us a pattern, but the data alone doesn't tell the full story. You, as the researcher, the person doing this test or whatever, know more of the contextual data that you can then layer that context on top of it to know what that actually means. Or maybe you just ask those questions that I said before and you dig into it a little bit more to figure out the answers to those questions. What is the difference between causation versus correlation? Those types of things. Those are questions you can ask and go deeper into this. So those critical thinking skills are what help us understand them. So in a world where stuff can be generated so quickly and so instantly, the real value, again, may not be just in calculating results. It's about questioning results. It's about analyzing results. It's about interpreting results. That's what's so important. Here's another quick example. This is just some sample-generated output from an AI. And if you are a good user of AI, and you want to be an effective user of AI, an authentic user, and not just taking stuff and using it, copying it, the first thing you should do is go through and look for some things, like, is this number, where does it come from? Is it sourced? Can I go validate that that number is true? You got to verify that. Think about the logic. Are they using some sort of logic that's flawed in their statement? And when I say they, I'm saying the AI. Is the AI using some sort of flawed logic that doesn't make sense for the situation you're in? Is there stuff that's missing? Like, oh, I actually need more information here. There are times where you can ask AI, like, hey, I'm working on this project. Is there something I'm forgetting? And that can be very helpful. I've done that before. When I'm doing a project, I was like, I have this, this, and this. Like, what else do I need? And it can help kind of identify those blind spots for you. But you, as the human, also have to take AI output it gives you and say, is there missing data here? Do I need to fill in some gaps? What other stuff do I need? So again, down here, just to keep hitting this point, the human job is not just about generation anymore. AI is good at generating. For us, it's about the verification. We need to actively edit the AI prompts. We need to refine them, cross-check them. I actually think this is, I think, a really good slide to kind of visualize what I'm talking about. And I like this better than that function example I had earlier. Because this shows here how humans kind of control the whole situation. And so everybody talks about like AI replacing us. But it's still us that create those examples. So if you think about it, we start the process by Brainstorming, defining what the goals of the project are. What do I want the AI to help me with? You need to explain all that context to the AI. And then you need to, the AI tool is the part in the middle where it processes it, analyzes it, and drafts. Notice it says it creates drafts for you. It's not final output, notice. And then the output for you is to fact check, to edit it, to refine it. If I were to do this graphic on my own, I would make this more cyclical because this should go back to here then. After you've refined it, you've made it better, you've changed some things, said this is right, this isn't right, then put it back into the system. And that's what will make it better. Because it should be an iterative process when you're working with AI. Use it as a tool, but it's not just a give me something and I'm done. No, that's a start. Now how can I use that to help? Again, it's a powerful tool, but it should not be a replacement for your thinking. So I'm going to circle back to those 3 questions that we talked about at the beginning. And that is, anytime you're encountering data or any sort of output from AI, think about these things. Where did the data come from? What assumptions are being made? What might be missing? Those will be some good guiding questions for you as you go through these. So I want to transition into a little bit of the human role. We talked about, again, a little bit ago about interpretation. Where did the data come from? Those 3 questions that were on the previous slide. What assumptions are being made? What might be missing? We are that tool in the loop that can provide those critical thinking. So in the age of AI, the most valuable skill, again, is not calculation, it's critical thinking. And how does this tie into math? Well, so many of the things that you're doing in your math classrooms tie in with those questions that I'm talking about. The math habits of mind, checking assumptions. When you're doing math problems, when you think about geometry, you have to think about what the assumptions are in there. You have to be able to verify things in geometry. I still remember, I can remember this very clearly. Funny story for any of you, there was a math professor here, Professor Wallach, who was a legend, amazing, and I had him for geometry here. And I still remember that one of my questions, and he was known for having very low points, which I always butted heads with him on, because you'd have an entire test, and the test would be worth like 6 points. And I missed like one of the questions completely, which if you missed anything out of 6 points affects your grade majorly. But it was because I hadn't proven, I had made an assumption that something was a rectangle, and I hadn't proven it to begin with, and so the rest of the problem was wrong. But that made me step back and realize that anytime in the future on these, I always can't make assumptions, that I had to be able to prove that before I moved on. Those types of things, those skills that you're learning in those classes like that, may seem, not important at the time, because nobody's ever going to stop me on the street and say, like, did you prove that was a rectangle first? No, but that idea of not making assumptions, going back and seeing that I have to actually prove the information was valid, accurate, those are things that are important as a life skill. Evaluating evidence. Being able to separate what sounds good, because a lot of things that are in AI sound really good. In fact, I would challenge you, when you are working with AI, to tell it what type of feedback you want. And what I mean by that is, again, for those of you that use it regularly, you'll know it's designed to be super positive, right? You could put in any idea, and it'll be like, oh, that was a great idea. And so I've learned, as I've been using it more, to help like design coursework or any kind of projects with teachers that I'm working on, I tell it that I want it to be a critical friend of mine. Like, I want you to be a critical friend. Don't always just tell me everything's great. Tell me when things are good, but also tell me when things may be better in a way. And so I've gotten, I feel like, better feedback from the AI tool. So don't be afraid to explain to the AI when you're using it what type of feedback you want. Because otherwise, by design, it's going to give you super positive feedback because it wants to please you. So because of that, because it wants to please you, it's going to make everything sound really good. And so you can't just take that illusion of authority that we talked about at the beginning and say, like, this sounds really good, it must be right. No, you actually have to evaluate whether it is. Question results, we talked about that too. Always question your results. If you think back to any of your math classes, even way back in elementary, they used to always say, like, did you check your answer? Does it work? Nobody ever wanted to take time to do that, but that's actually a valid step to do. And go in and say, is this result right? Does it work? And so that step that you're doing in math, just refusing to accept automatically that's right. I don't know how many times that when I was teaching, I'm sure any of the teachers know this, students will say, like, well, my calculator told me this was right. Well, that doesn't necessarily mean it's right. Did you even plug it into your calculator right? So you can't just assume, because the authority of the calculator back in the day was, well, that's got to be right. It came from the calculator. The same thing with AI. Just because you got it from AI doesn't mean that it's right. You can't just you can't just accept those immediately as right. And then identifying patterns. You should be able to, you're using your math skill to start making those connections and the relationships between the data, so that when you get results, you can actually tell whether it makes sense or not. If it fits the pattern that you're seeing, then it makes sense. If it's completely outside that pattern, then you may want to go back and, again, question the results, evaluate the evidence more. In a speech I had this morning, I had this on a different slide, and I first wasn't going to put it in here, but I wanted to pull this out specifically again, because I think it's so important. Because math, I'm sure I'm biased as a former math teacher, but I think math gets harped on more than any other content area of, when are we ever going to use this in the real world? Teachers always get asked that. And I get it. If you look at it in a very kind of a microscope as a one content piece, like, oh, when am I ever going to do graphing parabolas? Or when am I ever going to need to be able to find the derivative of this? And what does that mean for me in the real world? Think bigger picture. And that's what we talked about this morning. Math includes these 4 parts here. And if you weren't here this morning, these 4 things are life skills. Because decomposing is really just, in math, you have to be able to decompose a problem to figure out how to do it. And decomposing a problem is something you're going to have to do no matter what job or organization you're in. You're going to be faced with some sort of problem, and you've got to be able to fix it. It could be even, from working in some sort of like a philanthropic group. You could be working for Habitat for Humanity, or just working at your local church, or whatever. There are going to be things that problems arise, and you need to be able to break them apart to figure out how to solve them or get the work done. Algorithms, setting up a process to then have an event, to fix an issue, whatever it may be. Debugging goes along with critical thinking, like we've been talking about all day. Can you go back and fix the problem? If something doesn't work, then find out how to fix it. I feel like a lot of times people are afraid of failure, and failure should just be a way of learning. I love the acronym First Attempt in Learning. Failure is really just your first attempt in learning. If you fail, you failed, so what are you going to learn from that? So in that process, you should be debugging and figuring out how to solve it. And then the last one I said this morning, I talk about this all the time, because in math, there are these 8 math practice standards that are taught in all of the K-12 schools in Ohio. And one of them, math practice number 6, is attend to precision. And most people, if they don't dig into it, thinks it means precisely answer. Like, did you round off to the right decimal? Did you reduce your fractions? That's not really the essence of the standard. The essence of the standards is all about communication. Can you communicate precisely, and hopefully using mathematical language in math? But it's about communication. And if you pick up that skill from math, communication, it's such a huge skill in almost any job that you would ever have. So I really harp on those, because too often math gets dogged upon as this isn't something you're ever going to use in the real world. And it is. You're going to have to communicate. You're going to have to problem solve. You're going to have to be able to break problems apart and figure out processes to solve them. So I really, really strongly believe that if you focus on these skills, those will also help you be good critical thinkers, that when you start using these AI tools and people are like, oh, you're just using AI to cheat. Well, hopefully that's not what you're using it for. There are so many good positive ways to use it. But when you get that output, you have to be a good critical thinker, so that you are being responsible users of AI and not just absorbers of AI. So I want to circle back to the big question. I want you now to think about this question that we talked about at the beginning again. If AI can generate answers instantly, what's the role of human thinking? So now that you talked about it at the beginning, I want you to take another 30 seconds or 60 seconds and talk at your same people about if anything's changed or if it supported your thinking that you talked about at the beginning. Talk with somebody. All right. So whether or not these past 30 minutes ish changed your opinion from the beginning to the end, it doesn't bother me. I just want you to have that discussion. Because really, if you think about using AI and what the role of human thinking is, when people ask you like, oh, is AI going to overtake us? Remind people and think about these three things here. AI can generate information, obviously. And I've kind of had this conversation with teachers a lot about, like, what are we going to do now? They can just, write up a 3-page paper. Well, as a math teacher, we've had this for a long time, right? I mean, when calculators came out, people were worried about it. But even beyond that, like in the early 2000s-ish, there was stuff out like Wolfram Alpha already that would just solve math problems for you automatically. And so it was about learning the process along the way and all those steps and how to do things. Same with writing. I tell teachers now, we have to have those, the learning the process of writing is more important than the output at the end, the product, like that whole process. If we're worried about only the product, then AI could replace you. But if you're focusing on the process of learning, then that's where teachers and humans are still important in the loop. So AI can generate information, but it's still us that have to verify it. And so that is a key feature that you have to think about when using AI. Second, it obviously can identify patterns, but it's us that has to interpret that meaning of what those patterns are. Just like that simple data chart I showed you, that linear regression line there. Does that really mean what that means? I don't know. We have to dig in a little bit deeper, interpret the meaning. And third, it obviously can produce answers, but we have to decide if those answers make sense. And that's that whole idea of knowing your data well enough to know if that fits into the pattern. So, in this final message that I want you to think about as you walk away from here today is that math is not just about numbers. Think about the fact that artificial intelligence needs human intelligence. Because math should be teaching you more than just numbers. It should be teaching you about how the world works. So whether you become a mathematician, an engineer, a teacher, or any career out there that interests you, the ability to question information may be one of the most important skills that you ever develop. So truly think about that. It does not matter what field of work you're going into, question information. Because in a world full of algorithms, AI-generated data, images generated by AI, the most important processor out there is still the human brain. And that's why math still matters. So, anybody have any questions or thoughts? Mr. Bukowski.
I know we talked about this before, but can you give some ideas of what do you think is next for AI? Maybe the next progression or next improvements?
Yeah, so he brought this question up to me earlier about what do I think is next, and I really see it becoming more of something. Well, this is partly a little bit, I would say, a little bit rose-colored glasses, in one way. It's becoming a personal assistant, really. Like we have to, you're going to be using it for so many ways that you don't even think about, you know, because it's being embedded in so many of the devices that we use, and like I said, cars or whatever it may be. So I think it's about us becoming aware of what is being generated by AI. That's, I think, the most important thing that moving forward that we as humans need to be aware of. Because if things are being generated by AI, we have to then question them, whether they're actually accurate or not. Because that key in the middle of remembering that things that are created by them sound good, but necessarily aren't always accurate. So moving forward, we have to be more cognizant and aware of what is AI generated. Because there's so much stuff out there that, you know, whether it be images you see, videos that you see, whatever, and there's so many that are AI generated. So questioning. The other thing I talked to him about was just becoming more of a, almost like I said, a personal assistant, where it's doing some of those daily tasks for you. You know, I know that sounds a little bit like the Jetsons-ish, if for those of you that can remember or have heard of the Jetsons. But we have a lot of those things already. And so the other thing I think moving forward that we as humans have to think about is being responsible with it. You know, we had a conversation at lunch briefly with one of the students there about the environmental impact of it, but also the emotional impact. Because there are things out there called like AI companions already that if you haven't heard of those, where they can be like a friend. And they can be very harmful for anyone under like 18 because, you know, your brain is still developing and you're getting these connections that shouldn't be happening. So we need to be responsible users of it. But that also goes all back to this whole critical thinking thing, right? Like questioning things. But on the environmental part of it, you know, we were talking at lunch that I think that these companies are actually going to want to try to reduce their environmental impact too, because it'll, not because they're environmentally friendly necessarily, but it'll reduce their costs of amount of water and size of data centers and things like that. So that's my hope, because again, we don't want to use AI just to use AI. Like, it's no point in, I mean, I know it's fun, but like just typing in like silly questions into AI is just using energy that's not necessarily needed. So being responsible about that too. But I see it becoming more embedded, going back to your question, getting more embedded into our daily lives, and we have to be aware of that so that it doesn't become a replacement for us. I was having this conversation with him, and this is a little bit of a tangent from what he was saying, but I was having this questioning myself recently about how do you move from one chat tool to another chat tool? Because once you become heavily invested, I've really used ChatGPT a lot because I used it for my dissertation. So I've become so comfortable with it, but I've found other tools that I like, but I still find myself hard to go to those because how do you move all that data and information that it has about me, that it knows my tone, it knows my style? I feel like I was telling him it's like almost like an emotional divorce with the chat agent to move to another one. And I'm wondering that if at some point they'll make it easy to like transfer your profile over to another chat tool so that you can do that and not lose all that connection and background information you have with them. So I would just be cautiously optimistic moving forward. And I say that because there's a lot of good things that can come out of them, but you have to be willing to not just always accept everything face value. Question it because it's going to become more embedded into things that you don't even realize. All right, thank you guys. Have a good rest of your day. Yeah, thanks. You too.